Hello, happy people. This is Mr. Wilcox coming to you from my kitchen table. For the last part of Algebra 2 this year, we are going to use the unit circle, which is in the last page of your packet, or you can Google unit circle and just make sure that whatever unit circle you have has both radians and degrees. So we just talked about turning radians into degrees, and so what we're going to do is we're going to use the unit circle to find sine, cosine, and tangent, and today we're just going to talk about sine and cosine. So the unit circle, if we weren't in quarantine, we would actually make this, and we would actually find all of these degrees, and we would find all the radians, and we would find all our points using trig. But because we're in quarantine and it's a weird school year, we're just going to use the unit circle and find some information off of it. So a unit circle is the circle that has a center of 0, 0 and has a radius of 1. And at special angles, we can use trig to find exact x and y coordinates. So you'll find those on the unit circle, and on the unit circle, again, make sure whichever one you have has both degrees and radians. So in a circle is 360 degrees, and it turned all of the special angles into radians for you. All right. So here is what a unit circle looks like. Again, it's in the last page of your packet. Also, if you didn't get a paper copy of the packet, it is on the last page of the digital packet on Brightspace. It is also its own link on Brightspace. Also, you can just Google the words unit circle, and if you make sure that whatever image you pick, there are thousands and thousands of them, that it gives you both degrees and radians and the points, because that is what we are going to be using. All right. So what happens on the unit circle is actually very cool. It puts trig together along with right triangle trig, and it brings circles. And what it leads to is being able to graph trig functions, which unfortunately we won't get to this year. But it's a very cool thing that brings a whole lot of stuff together, why the equation of the circle is the way it is. A whole bunch of stuff. So it's a pretty cool thing. But what we need to use it for is we're going to use the points, because each of the points, each x coordinate is the exact value of cosine of that angle, and each y coordinate gives us the exact value of the sine of that angle. So every point is cosine and then sine. Again, if we were not in this weird virtual learning, we would have actually gone through and figured out why that happens and created the circle together. But again, you're just going to have to trust me that this is true. So here are our examples. We're going to find the exact value for sine and cosine given each angle. So I have one angle for you, and I have I have two angles for you, one in degrees and one in radians. So make sure you have your unit circle. And what we're going to do is we are going to, on the unit circle, find 225 degrees. 225 degrees is in the third quadrant, so it's below 180 and before 270, so 225. And our point at 225 is negative root 2 over 2, negative root 2 over 2. So our x-coordinate gives us our cosine. So our cosine of 225 degrees is negative root 2 over 2, or negative square root of 2 over 2. And then our y-coordinate gives us the exact value of sine. So our sine of 225 degrees is negative square root of 2 over 2. So without having to do any calculations from the unit circle, we know the exact values for the sine and cosine of 225 degrees. All right. 2 pi over 3. Remember, radians are just another way to measure an angle, and it comes from the circumference of the circle and the fact that there are 2 pi radians in a circumference of a circle. So there are 2 pi, if there's 360 degrees in a circle, there are 2 pi in a circle, or pi and half a circle. So to find 2 pi over 3, that's a little less than 1 pi, so that's going to be in the second quadrant. And so 2 pi over 3 is the same as 120 degrees, and our point there is negative 1/2 square root of 3 over 2. So remember, our x-coordinate is our cosine. So the exact cosine of 2 pi over 3 is going to be negative 1/2. And the exact value for sine of 2 pi over 3 is going to be our y-coordinate, which is the square root of 3 over 2, or root 3 over 2. All right, so there's our exact value for sine and cosine. So basically, you just have to look on your unit circle, find the angle you're given, and then if you're looking for cosine, give the x-coordinate. If you're looking for sine, give the y-coordinate. I hope that you're all happy. I hope you are all healthy, and I hope you all have a great day.